Hey everyone, this is Miss Cook with Lesson 2.4, and right now what I'm going to do is I'm going to introduce a few problems before we get into our lesson in the book. So this is 2.4 intro. Sorry, I'm writing with the stylus on my iPad, so it's a little bit messy, but just bear with me. So remember that the last week and a half or so we've been working with solving equations, and today's lesson is no different. As I told you guys the other day, we're just looking at equations that have infinitely many solutions and no solution. So the first equation that I'm going to show you guys is one like we've been solving. So if I have 3 times 4x plus 2 equals 20x minus 9x plus 2. The first thing that I need to take care of is this distributive property on the left side. So I'm going to distribute 3 times 4x and I get 12x. And 3 times 2 is 6 equals. Now then remember over here, I need to combine these like terms first. So 20x minus 9x gives me 11x plus 2. Now then, if you remember, a couple of you guys were confused on your quiz thinking that I had to subtract the term with a variable first. I had to get rid of that term first. Remember, I could get rid of whatever, the constant or the variable term. I just have to make sure that my constants are all on one side and my variables are all on one side. So for the case of this, let's just go ahead and subtract 6 so that you guys understand that I can do either order. So now that over here on the left side, I'm left with 12x equals 11x minus 4. Now then, to finish solving, I need to isolate my variables, so I need to get them on the same side. That gives me, I'm going to subtract 11x on both sides. These cancel, and I'm left with x equals negative 4. So, if you're wondering, this is an equation with one solution. And my solution is x equals negative 4. Okay? So now then, we are going to, I'm trying to figure out how to scroll down on this. There we go. So now then we're going to go over another example. And this one will be showing you what a solution with infinitely many, or an equation with infinitely many solutions looks like. So to start with, I have 2 times 3x plus 8 equals 2x plus 16 plus 4x. So remember, over here I need to take care of the distributive property first. So I'm going to distribute this 2 to everything. So I have 6x plus 16 equals, over here these are like terms. So I need to combine those first. So I get 6x plus 16. Now then, I'm going to go ahead and subtract my variable term from both sides. If you notice, they have the same coefficient. So what do you think's going to happen? This is going to cancel on each side. And I'm left with 16 equals 16. This is a true statement. 16 does indeed equal 16. So if you get a true statement here, we say that there are infinitely many solutions. Okay, and what that means is any value of x is going to work for this equation. Infinitely many solutions. Remember, if I'm going too fast in the video, you can just pause it and catch up in your notes. Okay, and then lastly, we're going to look at an example where there is no solution. So I have 4 times 9x plus 6, that's a 6, equals 36x minus 7. So distribute here, and I get 36x plus 24, this had an x, guys, sorry, equals 36x minus 7. Okay, if I subtract my variable term from both sides, what do you notice? That's right, they're going to cancel. And I'm left with 24 equals negative 7. Now, this is a false statement. They do not equal each other. If you get a statement that is false, there is no solution. And I forgot to mention to you guys in the last example, I meant to go back and talk about it because I wanted you to make sure that you knew how to solve. But if you look right here, I noticed that my coefficients are the same, but my constant terms are different, which means that my constant terms are going to produce a false statement because my variable term is going to cancel. So really and truly, in this step right here, I could have told you that there was no solution. Okay? And it was the same thing in this example. If you look back to this step right here, what did you notice? Well, my variable terms are the same and my constants are the same. Therefore, I know I'm going to have a true statement. So I know that there's infinitely many solutions. Okay? All right, you guys, there's going to be a few questions on here. And then you're going to go on to lesson 2.4 from the book. So that would be the next video.